next up, we will focus our attention more on some new frameworks, libraries that Apple has recently introduced. So Sharvil will be talking about exploring FSKit. So round of applause.
Hey everyone, sorry for that technical hiccup. Welcome to my talk on exploring FSKit, file systems, and user space. First off, huge thanks to Andy and Patrick and everyone who makes this conference happen. It's such a great location, great community, and I'm happy to be here. As is customary, here's my Who Am I slide. I like writing code, and I like creating security tools. Some of you may know me from my OS Query work. I'm a core maintainer of OS Query and on the technical steering committee. And for those who don't know, OS Query, it's an open source visibility agent, and I do paid consulting around it. Always happy to chat. Please reach out. This talk will be in 3 parts. We will first talk about a brief history of user space file systems on macOS, and then talk about a little bit of FSKit internals and how to implement one. And then we'll talk about a use case on how to leverage FSKit for detections and even deception. So my journey starts here. This is the macOS book before Jonathan Levin and Patrick and others carried forward the torch. I got this when I was a student, hadn't even learned programming. I had just got my Power book, even after the Intel one was released. I will also be the first to admit I have used it more as a monitor stand, but every now and then it has piqued my interest and I have scratched my curiosity and itch. It is still a great monitor stand, still a great book, because even to this day, some monitors don't come with a stand. Amit Singh is also the author of MacFuse. He started this at Google back in 2007. So he wrote a VFS kernel extension and a bunch of user space libraries and programs to enable user space file systems on macOS. One of those file systems was SSHFS. I really loved SSHFS. Back then, I was helping people host their movable type and WordPress blogs on Apache and PHP Linux boxes. And this was so convenient. I thought it was the bee's knees. This also enabled some of esoteric file systems. This is one from back in the day called Objective-C Runtime FS. Basically, it will show up all the Objective-C classes as directories and all the instances of it as files. There were a couple of other esoteric file systems that Amit Singh and his team at Google wrote. One of them was like Accessibility FS, where all the accessibility settings were displayed as file systems, and you can write to it and move elements around. But the main one that kind of piqued my interest was ProcFS. It was based on the historical Unix one brought to macOS. So one could just cat/proc/CPU info and get details of the CPU. Similarly, one could just cat proc PID number and get all the details of that process. I thought this was a really cool idea. It was very elegant, very Unix-like, and exposing system internals and telemetry this way stuck as an idea with me. OS Query also does this. It exposes OS data as a virtual SQLite interface. And macOS is Unix, right? So everything is a file. Yeah. So that sets the context. I want to fast forward to FSKit now. Apple has been trying to move components away from the kernel and into the user space, and for good reason. Increased stability, reduced attack surface. We saw this with DriverKit. We saw this with endpoint security. And I think FSKit is just another component in that process. Based on educated guesses, I think FSKit has origins on iOS with the Files app introduced on iOS 11. Files app was updated in iOS 13 to support mounting USB drives and Samba share, so you could just plug your USB pen drive or your SD card and it will show up. Now, I'm not a reverse engineer, but I do like to poke around and try to build a mental model of newer stuff. So here we have the LIFS kex that Apple has written. It's called Live File System, which plugs into the VFS switch. If you do ls VFS on your terminal, you see all the file systems connected to the VFS system. Then we have the LiveFS private framework. Next to it is the FSKit public framework. There's also userfs framework that's present on macOS, but I don't think it's being used. I think this was probably used on iOS. And we have our old disk arbitration framework to help with the mounting. So I'll use IO registry to quickly skim what's going on and try to understand this a little bit better. Here we have 3 instances of the Apple LIFS user client classes. We have their PID and their process names. The first one here, PID 4361, is FSKit daemon. The second and third one, their names seem interesting or truncated, so let's kind of dive into that. Again, I'll use OS query to get that process info. So that name is Apple FSKit exFAT, so they've implemented exFAT as a userspace LiveFS file system. The path is the system library one, but I'm intrigued by the command line arguments. There is launch arguments there, but that looks like base 64 encoded, and I don't know why Apple would thought of doing that. So let's just try and decode it, and yeah, it is in fact base 64 encoded, and it gives us this blob. There's something called type, which is set to 1 for this exFAT extension. There's something called enhanced security that's set to false. I don't know if this is the new enhanced security on Xcode or not. And that's the service name. There's another FSKit meta module, which kind of does module management. Here, also, the launch arguments are base 64 encoded, but here the type is 2. Again, I don't know. I haven't really looked into it, but something to look into. And we have 3 kind of main FSKit binaries. One is the FSKit daemon, the other agent and a helper. And the daemon is the more interesting one. It links to disk arbitration for mounting. It connects to the private LiveFS framework, and it proxies the request to the LIFS kernel extension. So quick recap, I think file systems are pretty cool and essential. Apple is on the path to move components out of the kernel. FSKit has origins on iOS, and it's now being ported to macOS. FSKit modules are app extensions, which is interesting, and FSKit is the userspace daemon that kind of brings everything together. So next, let's try and implementing a file system with FSKit. There are 3 major concepts here. First, we have the FS volume, which is just a place for your directory and files. Then we have FS resource. This is just a backing data store. So if it's a block resource, that could be /dev/whatever disk. But Apple supports 3 different kind here. The FS block device resource, but the 2 ones are a little bit more interesting. The path URL resource and generic URL resource. They just appeared brand new in Tahoe. And together, this forms the FS container. Currently, there's a limitation of FSKit where for a container, it can currently only support 1 volume and 1 resource, but from the documentation and from Apple developer forums, I think they're planning to make it work with multiple volumes and multiple resources. Next, we have a code which, where we implement the file system operations. And then we have our info plist and attributes, and together this makes the FS module app extension. Now, user interaction is required to enable the FS module. And on the left, you can see all the FS modules that I've implemented. I've been playing around with a bunch. And on the right are the Apple ones. I cannot toggle them. They are grayed out. And I have that asterisk, interaction required, because it's not going through TCC. You can easily kind of bypass it. There's a writable plist on disk, at least in one of the betas. I don't know if Apple considered this a security issue or not, but moving on. Let's look at that info plist a little bit closer. We need to give it a name and give it some capabilities. Here, I'm setting the objects are case sensitive to false. And I mentioned the block resources or the resource types. So here are all the 4. This requires a little bit of fiddling because Apple's documentation was very sparse, is still sparse, but at least your header files are somewhat documented. So here, I'm not supporting block resource. I'm not supporting generic URL resource. I am supporting a path URL, and there's something called server URLs, which I don't think is supported, but it's there in one of the attributes. So next, we need to implement the sysfs class, which needs to conform to the unary file system operations protocol. We need to implement three things: probe resource, load resource, unload resource. So here, probe resource is pretty simple. Since it's just a path URL, I just make sure it's the type I expect. And then I just set the file name and the container ID, which is just a UID, and mark the probe result as usable. Similarly, for load resource, there's nothing to load here, basically. So you can set the container status to ready and just let it fly. And similarly, for unload, there's nothing to unload. So yeah, just a debug statement. Next, we'll look at sysfs volume implementation. So we need to give it some supported capabilities. There are a bunch of them. You can mix and match based on your requirements. Here, I don't support journal. I don't support hard links or symlinks. I don't support hidden files. Case format is incentive case preserving. Yeah, it takes a little bit of trial and error. The documentation is still in flight. And most of the things I've stubbed out. So here, if you try to read a symlink from there, I just throw error. If you try to create an item, throw an error. Even write to something, create an error. But I did implement read, which is kind of simple. It just takes a fs item, an offset, int, and a buffer. And here I'm doing something kind of like procfs, like a pseudo file system. I'm just doing a basic check, like if the name is hello world, just get hello world. If the name's time, then it'll use the time API, kind of like what OS query does. And there's one called tripwire, which if you kind of read that file, it will just send a notification somewhere that this file has been accessed. And since I'm not writing a GUI, there was no documentation on how to kind of mount this. So app extensions are kind of maintained by plugin kit and extension kit. So I figured out a way to kind of run this. It is also possible to do auto-mounting programmatically, and based on Apple's dev forums, there are plans, but right now I've been just instructed to shell out to mount, and disk arbitration also just does that. So on the mount call here, I'm just forcing it. The -t is the type, which is my implementation sysfs. I need a backing store, so it's a dummy random data file, and wall is my mount point. So again, I'm going to use OS query to check if it's mounted, and here you can see the last line. So that dummy random data file is the file handle is the kind of path, and the path with the volume is my mount point, and it says the type here. Thankfully, this does spit out ES mount event. I hope this is readable. I wanted line numbers here so that I can point to things. So here we can see this is the event mount, and it gets fired. The FS type name is sysfs, and we have the mount from, mount to, everything is expected. And on the right, you can see the responsible process that was user libexec FSKit that did the mounting. Similarly, open events are also emitted. So here I just ran file on one of those tripwires. And on the right, you can see down in the bottom, the responsible process was user bin file. So that's great. So quick recap, we can write custom file systems. FSKit makes it super simple to write user space file systems. I think it's pretty cool, but I think there's also a little bit of MacFuse nostalgia for me. But the interesting bits are you control not only read and write operations, but symlink operations, xadder operations. And this opens up a lot of powerful detection use cases. Let's say, for some reason, if you wanted files that are created or modified in that mount point, you can stamp the quarantine xadder every time that file is created or modified. If you have compliance needs, every read on those files can redact PII. And since it's almost compulsory, here's my obligatory AI thing. You can just use AI to populate a canary file system. And Patrick had an amazing blog post, all his blog posts are amazing, on generic ransomware detection. I think that was almost a decade ago. But I think this brings all those kind of pieces together to actually create one. Next up, I want to talk a little bit of the use case here. So the use cases of canary files and honeypot. So on the left, first of all, why do we want this? I think as macOS malware matures, it probably will move away from shelling out, and it'll become more and more complicated. So I think we also need to evolve our detection strategies and move towards a more proactive detection posture. We basically need to bait bad actors, right? So Thinkist does this with canary tokens on Windows. Windows has projection FS and filter drivers. So here, the way we are doing this is we have two sets of watch paths. On the left is our canary files backed by FSKit, and on the right are actual files that are sensitive to me that I really want to protect it. SSH keys, AWS tokens, keychains, what have you. We configure our ES client, set up appropriate tripwires, and we are off to the races. Whenever something happens, we set off an event to the SIM, and then alerter alerts it. FSKit makes this super easy because we can package it up as an app or an app extension and can use MDM to deploy it to thousands of machines. Because creating file systems, canary file system by hand would be kind of pain. And this is not just theoretical. This has been successfully deployed across thousands of Macs. A client had reached out. They had an external pen test and needed file access monitoring. We had set up tripwires and set up watch paths, both as canary and sensitive ones, and did some custom work for notifications and stuff. When they got tripped, it creates a GitHub issue with all the details. This was just before FSKit was usable, so I had to do a lot of work to create those canary file systems. A bit of a plug, I do consulting. If anyone's curious about this, wants help with OS query, come talk to me. Also, I talked to a bunch of people here who use OS query but are not aware of this feature. I use this personally. I have watch paths set on my SSH keys and my keychain, and every time someone accesses it, I can access and go back. So here, like on the bottom screenshot, you can see the file name. My public key was opened by that bat thing. Thankfully, it was me who did that. But you can see my keychains being accessed by Apple framework, so it's all kosher there. But it's a great way to get notifications and even stop things like infostealers in your tracks. If you haven't looked at ES muting, path inversions are great APIs. Utilize that. And as it happens, Google just announced this ransomware protection for their Google Drive on 30th September. This is basically what they do. I don't know if they're using FSKit yet, but I'll highlight here a little bit. An attempt to encrypt or corrupt files en masse is how they do detections, and then they just cut off the syncing if they trip that. So takeaways. We need to bait people, or not people, the bad actors, to kind of better our detections. We can use ES muting, file access monitoring, and FSKit to kind of tie it all together. If anything, that's the takeaway, and thank you so much for your time. Questions?